Hello everyone, my name is Mr. Kabaya. We'll be together in chemistry, and today we're going to look at matter, or the particulate nature of matter. So we'll define what matter is, then we'll also look at the properties of matter. Okay. So the definition of matter, we say that matter is anything that occupies space and has mass, or it has weight. So matter exists in three forms. So it exists as a solid, it exists as a liquid, and a gas. These forms of matter, they are what we call the state of matter. So the forms of matter are what we call the state of matter. So these states of matter, they are being made up, they contain certain particles. And those particles that make up the states of matter are called the basic units of matter. So look at what we call basic units of matter. So the basic units of matter, we have got molecules, then we have got atoms, and we have got ions. So we have said matter exists as a solid, liquid, and a gas, and for this to exist, the basics of matter are the ones that make up what a solid is, what make up a liquid, and what make up a gas. So the states of matter, they have got properties. So each has got different properties. So if you look at the properties of these, the properties of states of matter, so among the properties, we have shape, then you have got the volume, and you have got compressibility. So here we're going to try a solid, we're going to put a liquid, we're going to put a gas. So we want to know some of the physical properties of the states of matter. So for a solid has got a fixed shape. It also has a fixed volume, and we cannot compress a solid. It cannot be compressed. For a liquid, so these are called the physical properties, and when we look at how the particles are arranged in a solid, liquid, and a gas, we will know the reasons why they have got fixed shape, fixed volume, and why it cannot be compressed. So for a volume, the shape is not fixed because it takes the shape of the container. So this is not fixed. It has a fixed volume. And because the particles in a liquid, they are spacely packed, it means we can place it. Then for a gas, it has got no fixed shape, no fixed volume, and it can be compressed. So the physical properties, we talk about the shape, we talk about the volume, and we talk about how is this property going to be, can you compress a solid, can you compress a liquid, or can you compress a gas? From here we're going to look at what we call kinetic particle theory. So the kinetic particle theory, it states that matter is made up of tiny particles that are in constant random motion. So this one states that matter is made up of tiny particles that are in constant random motion. This is a solid, a liquid, and a gas. And we are saying that the solid contains these tiny particles that are in constant random motion. So what the kinetic particle theory tells us is the arrangement of the particles, the movement of particles, and also the force of the particles, the force between the particles that are found in a solid, and a liquid, and in a gas. So using the kinetic particle theory, combine it with the states of matter, we're going to look at how the particles are arranged in a solid, in a liquid, and in a gas. So in a solid, the particles, they are orderly and they are closely packed. So we need to write the particles in a solid. So in a solid there is order. Then in a liquid, the particles are disorderly and they are spacely packed. So the particles in a liquid, they are close, but not as close as the particles are in a solid. Then in a gas, the particles, they are disorderly and far apart. So the particles are disorderly and they are far apart. Okay, so because this one deals with kinetic means motion. So if you talk about the kinetic energy, the particles in a solid, they have got low kinetic energy, very low kinetic energy, so very low kinetic energy. This one, they have got a low kinetic energy. And here, the particles in a gas have got high kinetic energy. So because of this energy, the particles in a solid, they do not move, but they vibrate. So the particles vibrate on a fixed position. So you can see they vibrate and rotate on a fixed position. The particles in a liquid, they move by sliding past each other. Then in a gas, these particles, they move randomly. So the particles in a solid, they vibrate and rotate on a fixed position. Whenever you're answering a question that involves you writing on the movement of particles in a solid, we're not supposed to leave out fixed position. So you always state vibrate and rotate or just vibrate on a fixed position. Then in a liquid, these particles are able to move, sliding past each other. That's why a liquid is able to flow, because the particles are sliding on each other. In a gas, the particles move randomly. So in a gas, particles move in different directions. That's how we're saying randomly on this part. Then because the particles are closely packed, if you talk about the force, the particles in a solid, there is a strong force of attraction. So here the force of attraction is much. So here there is a strong force of attraction. Strong force of attraction. Here the force is a bit weak. So weak force of attraction. And in a gas, very weak. So the force in a gas is very weak. Some books they'll say there is even no force. But in a liquid, the force is weak, and in a solid, the force is very strong. That's why the particles are closely packed. So this is the kinetic theory and the states of matter. We're explaining what the kinetic theory states within the particle, within the forms of matter, which are solid, liquid, and a gas. Okay. Now we're going to move forward and look at what we call the changes of state. So look at what we call changes of states. So a change of state, it means that a substance is changing from a solid to a liquid and to a gas. Since we have said that matter exists as a solid, a good example is ice. It can exist as a liquid, a good example is water, and it can exist as a gas, a good example is the water vapor. Now a substance is able to change from a solid, which is ice, you melt it, it goes to a liquid, you heat it, a liquid, you go to a gas, and that process is called the change of state. And the change of state is brought about by two effects. Those effects are heating and cooling. So a substance changes its state because of heating or cooling. So the heating and cooling will bring about what we call the changes of state. So we have a solid in which the particles, they are in order, they are orderly. Then I've got a liquid in which the particles are disorderly, but they are closely packed or spacely packed, but not as close as those that are found in a solid. Then you have got a gas in which the particles, they are far apart. So a substance is able to change from a solid to a liquid, and a liquid to a gas to a liquid, and a liquid to a solid. There's also a change of state That occurs from a solid to a gas, which is a direct change, and also from a gas to a solid. It's also a direct change. So the change of state where a solid changes to a liquid is called the melting. A liquid changes to a gas is called the evaporation. A change of state from a gas to a liquid is called the condensation. And a change of state from a liquid to a solid is called the freezing or solidification. Then the direct change from a solid to a gas is called sublimation. And also this one is called the sublimation. So because these changes, they occur either because of heating or cooling, so we can differentiate the sublimation, either it's sublimation on heating or on cooling. So when you are changing from a solid to a gas, the sublimation is called now on heating because we are applying heat. In this one, we are removing heat, that's how we are cooling. Okay. So for a substance to melt and for a substance to evaporate, there's a form of energy that is being added. And also for a solid to change to a gas, we are adding some form of energy. So in chemistry, the chemical reaction that involves the addition of energy or the taking in of energy is called the endothermic reactions. So I've got endothermic reactions or process where energy is taken in. Energy is added. And for a substance to condense, meaning that you are removing heat, and to freeze it, meaning that you are removing heat, and also sublimation cooling, heat is being given out to the surrounding. That process is called the exothermic. So energy given out. Under endothermic, energy is added. Then under exothermic reaction, energy is being given out. So from the states of matter, we can see that melting and evaporation are examples of endothermic processes, while condensation and freezing are examples of exothermic processes. Now, what happens when a substance is heated? When a solid is heated, it changes to a liquid. Now, what happens to the particles inside a solid as the energy is being added? So, since we have said the process of changing a solid to a liquid is called melting. So under melting, and you have said that you are adding energy. The particles inside the solid, as you are heating it, the particles, they gain kinetic energy. So the particles gain kinetic energy, and they'll start to break out from each other because they're trying to overcome the forces of attraction between the particles. As they are overcoming each other, they will start to vibrate more and they'll start flowing like particles in a liquid. That's how a solid changes to a liquid. Then what happens when a liquid is heated, which is evaporation? Again, the particles, they will gain kinetic energy. So when these particles gain kinetic energy, they'll start moving fast. As they're moving fast, they'll start behaving like particles in a gas. That's how a liquid changes to a gas. The particles will gain kinetic energy, they'll start to space up. After spacing up, they'll start moving fast like particles in a gas. For a solid, it's the same. The particles will gain energy, space up, they'll start moving like particles in a liquid. That's how a solid changes to a liquid and a liquid changes to a gas when energy is added. Then when you are removing energy under exothermic chemical reactions where energy is being given out, under condensation, the particles lose kinetic energy. So they lose kinetic energy. When they lose kinetic energy, the particles in a gas will stop moving fast because they have lost kinetic energy, and they'll start getting closer to each other like particles in a liquid. That's how a gas changes to a liquid. Then during freezing, the particles again, they lose energy. After they lose energy, they'll start moving like particles in a liquid. They'll start getting closer to each other and they'll start behaving like particles in a solid. So instead of moving or sliding on each other, they'll start vibrating on a fixed position like particles in a solid. So that's what happens to the particles when energy is being added and when energy is being given out. Okay. So let's look at an example now. We can identify the changes of state. Okay. An example on the changes of state, we say identify the following changes of state. So identify the following changes of state. So we need to identify what A is, what B is, what C is, and what D is. So in this question, we have been given the arrangement of particles. So we can see that here, because the particles are orderly and they are close to each other, it means this is a solid. Here the particles, they are close to each other, but they are disorderly, it means this is a liquid. Here the particles, they are disorderly and far apart, meaning that they show that the presence of particles in a gas. After identifying what these are, that's when we can identify the changes of state. So A, we can say that A is a change of state from a solid to a liquid. And from a solid to a liquid is called the melting. Then B, we have a liquid, and here we've got a solid. So the change of state from a liquid to a solid is called the freezing. C, we have a liquid that is changing to a gas, and this change of state, we call it evaporation. Then D, we have got a solid that is changing to a gas, and this is called the sublimation or heating. Okay, so we'll be able to identify the changes of state and also give examples of an endothermic process and exothermic process if you know heating and cooling, whether energy is being given out or energy is being taken in. So today we have looked at matter, we have defined what matter is. We have looked at the forms of matter, which is a solid, a liquid, and a gas. And we have mentioned the basic units of matter, which are molecules, atoms, and ions. Then you have also seen that we have also mentioned about the kinetic theory of matter, which states that matter is made up of tiny particles that are in a constant random motion. And we have also looked at the changes of state, where we have said a substance is able to change a state from a solid to a liquid and to a gas simply because of two processes, heating and cooling. Thank you.